Hi developers, welcome to this Lightboard session where I'll be explaining the road to Kubernetes. So we'll take the scenario of having an application where we have a web app running inside an application server that connects to a database engine. We'll try to Dockerize this application using Docker containers. Then we'll run those two containers using the Docker Compose, so we'll have the connectivity between those two containers or those two services. After that, we'll run this app in our local machines using MiniCube. And once we are ready, we can go to deploy the app into a real Kubernetes cluster. So let's start showing the scenario for our app. So we say from here we'll have a web app, and also we'll have a database engine. This could be SQL Server or whatever database engine you are using. So in traditional approach, this web app will run inside an application server, Apache Tomcat or IAS in case of the ASP.NET applications. And the database, we can have here Oracle, MySQL, SQL Server, or whatever database you use. And in the traditional approach, this database engine will be installed directly on the virtual machine or the physical server. So that's the traditional way of running applications. And we'll have here, of course, the code source for the application. So we'll have here the different source code files where we have the source code for the application. And in order to deploy or to run this app, for example, let's say this web app is an ASP.NET Core application, then here I need to run the commands specific for ASP.NET Core. So we'll have the commands, for example, for .NET build in order to build the project and restore all the dependencies. And once that's done, we can run the app, and we can do that by running the command .NET run. .NET run will try to run the app, and because we have configuration inside the app, we will try to connect to the database, which should be always up and running. So this is the traditional approach of running applications. Now we'll move to Kubernetes. And before that, we need to create the Docker containers that will run this web app and the database. And the reason why we want to move to Docker is that we'll have less dependencies of the virtual machine that will run those applications. So all the dependencies will go to the Docker container. In addition to that, later with Kubernetes, it's easier to scale the application and to make sure it is always up and running. And the composition of different services will be easier using Kubernetes. So now, in order to move this application into Docker, all we need to do is to use the Dockerfile. So from here, let's say I want to go to use Docker containers or container. That could be Docker or any other container runtime like Creo or
Linkerd.
So this is the phase for containerizing the application. So we'll have a Docker container for the web app and another one maybe for the database if we want to do so. So for that, we'll have the notion of the Docker file. The Docker file contains all the instructions needed in order to create a container that runs my application. And generally, what we found inside this Docker file are the commands .NET build and .NET run, the two for building and another one for running. So we'll try to use a specific container to build the application. Of course, we need to copy the application's source code inside that container. then we'll run the command to build the application inside the container. Then maybe we want to use another container in order to run the application, and that's what's called the multi-stage Dockerfile. We use different containers to perform different tasks. The reason why we do that here is to use a specific container that is optimized for running the application and that contains less dependencies and less programs installed inside of it. For example, to run the app, I don't need to have the SDK installed inside the container that will run the app. So in this case, in this phase right here, we'll be using the Dockerfile. And with the Dockerfile, we have the commands for building the Dockerfile to generate the different images. Then we'll have another command for running the Docker containers that were generated previously by Docker build command. And here for the database, we can use, or we can even choose to not use Docker files for the database. But if we choose to use the Docker file, then what we want to do is to choose, of course, the container that we want to use. Then maybe we want to run the scripts for deploying the schema for the application. So we'll have SQL scripts inside the Docker file that will be launched when we want to create a new database or to update the database, the existing database schema. So in this case, we'll have two containers, one for the web app and another one for the database engine. And each time we want to run the application, we need to run those two containers using two different commands. But here we have only two apps, but imagine that we have a microservice application where we have dozens of containers. So we want it's not fun to run each Docker container with its own command. So we need a way to compose those different containers and to run them with a centralized configuration where we can specify all the containers that should run, and we can also add the connection or the connectivity between the different containers. Here I have my web app that should connect to my database. Inside the connection string for my web app, that should include the URL for my database. So how can we do that? And actually here where Docker Compose comes into play. So let me draw that here. So we'll go from our container, and here we'll go to use Docker Compose. So we'll go inside this phase, and here we'll be using Docker Compose. The role of Docker Compose is to compose multiple services that we have. So here, as we said, we have two containers, and we'll have connectivity between those two containers. And at the end, Docker Compose is a file, like we have the Docker file, and this is a YAML file. So we'll have something called Docker Compose.yaml. Of course, you can change its name if you want to. And this file, so it will contain the configuration for my two containers. This means it will define my app, and it will also define my database. And inside my app, it will say this needs to run the container for my web app, for example. And the database should run another container for the database, okay? Saying that this web app is the container for my web app, and the database is the one for my database engine. And here, because we have different services defined inside the Docker runtime or the Docker daemon, here the app could reference the database service. This means inside the connection string for my web app, I can use environment variables to reference this DB. So in each time this DB will change its URL or its IP address, the app will be always conscious about this change, and as a result it will also change the URL of the connection string. The Docker Compose also have its own commands in order to build it and run it. So we'll have the command Docker Compose build. This will build the different containers described right here, and it will create the configuration. And another command is the Docker Compose app. This one will be used in order to run the containers that were described inside the Docker Compose. But in this environment, this is actually easy to set up, because here I just need Docker to be installed on my machine. But the drawback here is that I'm not talking about Kubernetes here, and at the end for me I want to deploy into Kubernetes, and Kubernetes have its own constraints. It's a bit different than this environment, so I need something that enable me to deploy into Kubernetes but still working on my local machine, on my development machine. For that, we have solutions to create a full Kubernetes cluster. Here we will not be talking about a cluster that contains tens of virtual machines, but we can create actually a simple cluster that contains only 1, 2, or 3 virtual machines at the most. And that's what is called MiniCube. So from here we can either use Docker Compose, or we can also use MiniCube. And with MiniCube we'll have a simple cluster. It's a virtual machine actually that contains Kubernetes installed. This will simulate having one node cluster where we have the controller plane and the agents installed inside the same virtual machine. This is enough for development purposes. And what is good about MiniCube is that we can manipulate it, and we can configure it as the same way we do with the real Kubernetes cluster. This means from here we'll be using the same Kubernetes manifest files that we'll be using later from with Kubernetes. So here, when we move from containers to a MiniCube, we'll need to use those manifest files. So let's give a brief introduction about those manifest files. So those are specific to Kubernetes, and those are YAML files, of course. Those, as Docker Compose do, they describe the configuration of the app, the different containers that should run, and the different services that should run inside the app. And the services are the ones that will be used in order to map or to enable connectivity or between the different containers. They contain also the configuration to attach a disk to my virtual machines or to my pods. They contain also configurations to say, for example, this container should not go beyond using 300 megabytes of memory and 1 CPU, and so on. We can also define the health check and config files, and the secrets to store sensitive data, and so on. And here also another advantage of MiniCube is that we can use kubectl. kubectl is the CLI tool, the client CLI tool, in order to connect to the Kubernetes cluster. And from here, of course, you can use the command kubectl apply, then my config YAML files, in order to send those manifest files into the Kubernetes cluster, and my cluster will read those files and apply the configuration there. And once we are done with testing in our local machines, either with using Docker Compose or MiniCube, now we are ready to move to deploy into Kubernetes. So let's do that here. And the deployment into Kubernetes means that we will copy or we'll send those YAML files into Kubernetes cluster using the same command kubectl apply -f. Of course, here this should be apply, not apple. Kubectl apply -f, then your conf file.yaml. Now it's about this Docker Compose file. We created this file and we used it inside our local development machine, but can we still use it with the Kubernetes cluster? Because here we have used those Kubernetes manifest files. So here, actually, if you invested a lot of effort creating this Docker Compose file, you still can use this same file in order to deploy the app into Kubernetes using the Docker Compose instead of those manifest files. That's a project initiated by Docker, the company that created the Docker containers, but that's not actually mature enough. So for now, I see people, most of them are using those YAML Kubernetes manifest files. And here for Kubernetes, some people create actually multiple clusters or multiple namespaces in order to create different environments. Because here, before deploying to production, maybe I want to have another environment or a separate environment for my dev and another one for test and another separate environment for production. And here, so we can make this separation, we can make a logic separation by using different namespaces. Or we can have multiple clusters. This means a cluster for dev, another one for test, and another one for production. I hope this video gives you an overview of by going from a traditional web application to containerizing it, deploying and testing inside our local machines, then deploying to Kubernetes. I hope you liked the video, and at the end I would say thank you. Don't forget to subscribe to my YouTube channel, and also don't forget to follow me on Twitter. My handler is @HussamDelai.